Hey guys, welcome. Let's get started on our evens video 10.7. Find the area of each of the following. Leave your answer in terms of pi. So I'll be doing the evens. So our first one is triangle AOB. So we have a triangle AOB and it has a 60 degrees in there with a 7. So you're kind of lucky. This is the hardest one. 1 second. There's my neighbors making some noise. Okay, so here's our triangle. Drop down this because we got to find the area of it, and that's going to make this a 30/60, and our radius is 7, so 7 is kind of this hypotenuse here. So this is in the 2s, so this is going to be 3.5 and then 3.5 rad 3. So our area of a triangle is 1/2 base times height. Well, the full base is going to actually be 7. You know it's equilateral, so I'll number 7. So 7, and then the height is 3.5 rad 3, and then take half of that. So 7 times 3.5, 7 times 3.5, then times rad 3, and then divided by 2. And so leave your answer in terms of pi. This one doesn't require to be in terms of pi, so we're just going to do 21.2. And so that's the area for number 2. So when it asks you to find the shaded segment is right here. It's kind of hard to actually see, but what you have to do is you actually find the area of the sector. So it's the sector minus the triangle, and that's going to equal the segment. Well, we actually already have the triangle because we found it in our previous one. And then the sector is found by doing the measure over 360 times, and then this is just times pi r squared. Sorry about, there's construction next to it. I don't know what else to do about it. So anyways, so we get the measure is 60 over 360 times pi 7 squared. Okay, and so we just do, that's becomes 49 pi, 60 divided by 360 is 1/6, so we can get 49 over 6 pi. And so actually this is in terms of pi, how you would want to write it, just like that. So this is 49 over 6 pi, and then subtract, and that's actually your answer, because once in terms of pi, you would just leave it like that. If it wasn't in terms of pi, then you could just evaluate that in your calculator, and you get like, I think 4 point something. I don't know. I think. Let's see. Yeah, you get 4.45 about. Alright, number 6. Find the area of the following. Leave your answer in terms of pi. So again, here we're finding the triangle. This one's a lot easier because it's a 90, so this is 0.5 and 0.5. So the area of the triangle is just going to be 1/2 base times height, which they're the same because they're 90. So it's 1/2 of 0.5 times 0.5. So 0.5 times 0.5 divided by 2, you get 1/8. And then number 8, the shaded segment. Again, you have to find the area of the sector, and then you're going to subtract the 1/8. So same thing here, it's the sector minus the triangle. And so we get 1/8 here, minus, and then we just have to find the sector. Again, to find the sector, we're going to do 90 over 360 times pi 0.5 squared, and so 90 over 360 is 1/4, and 0.5 squared is 1/4, and 1/4 times 1/4 is 1/16, so you get 1/16 pi, or you could do 16 over pi like that, which is fine, and that would be your answer in terms of pi right there. Alright, number 10, find the area of the shaded sector. Okay, so this is going to be 36 as our measure over 360 times pi 6 squared. Again, in terms of pi. That didn't sound good. This is going to become 36. And so I believe we just want to leave 36 over 10 pi, which would reduce to 18 over 5 pi. Sorry, a little off the screen on that one. Number 12. So we can actually just add these two together. So 90 plus 45 is going to be 135 over 360 times pi r squared. And so that's going to be 4 pi times 135 over 360 reduces to 3/8 times that by 4, and we get 3 over 2 pi. 14, this is 120, so that means this must be 60 because that's the add up to 180. So we're going to get 60 over 360 times pi r squared. That's going to be 6 because the whole diameter is 12. So that's 36 pi times 60 over 360. So we should just get 6 pi for that one, for 14. Okay? 15. 15 here, we have everything but 45, so we can just do 360 minus 45, and that's going to be 315 over 360 times pi 3 squared. So it's going to be 9 pi times that. That's going to be 63 over 8 pi. Again, these are all in terms of pi, that's why we're doing. Oh, I accidentally did 15. I was supposed to do 16. My bad. You got lucky. So I'm not going to do 16 yet. Alright, and I think these are the last 3. And I'm not going to do 18 because that's a 90 degree. That one's actually pretty easy to do. I'm just going to do number 20 here. So we have to find the triangle. So whenever we're doing a segment, you have to find the sector. And then you have to subtract the triangle, right? Okay. So for the sector here, so we're going to have a side length of 4. This is 60, this is 120. So for the triangle, you have 120. And this side length here is 4. So when you break this down, you're going to get 60, 30, and then 90. So that's 2. This is 2x, this is 2, and then this is 2 rad 3 for the triangle. Okay, using our special right triangles here. This means this is also 2 rad 3, so this triangle, the area is going to be 1/2. That's going to be the base, which is, add those together, it's 4 rad 3, and then times the height, which is 2. Okay, so we're going to end up with, I believe, it's just going to be 4 rad 3 as the area of the triangle. Now the sector is 120 over 360 times pi 4 squared, because that's the measure of our radius. And so that's going to be 16 pi times 120 over 360 reduces to 1/3. I don't think it goes in evenly, unfortunately. So we get 16 over 3 pi. So these are the two things we're going to subtract. So actually, this is kind of a wild answer. That would be your final answer. Now, if we evaluated this, our decimal equivalent would be roughly 9.8. Okay? So that was number 20. Okay, so area of the sector, area of a triangle, subtracting, that gives you the area of this segment. Alright?